All right, guys, so this is day 2 of notes. Um, it's going to consist of me just going over how to use a change of base formula because I noticed a lot of people messing up the homework yesterday. I think it just had to do with Mr. Mostella's video being a little bit unclear. And then it's also going to have what's new for today is the properties of logarithms. So just as a recap, so back before the spring break and all this going on, whenever we were evaluating logarithms, you would write in the y equals, then write the conversion. So this would be, this is in the form y equals log bx, logarithmic form, converts to be in the form x equals b to the y, exponential, because remember that's how we solve logarithms, so we change it to exponential form. So when you convert, it'll say x or 8 equals 2 to the y power. And then you would change the 8 so that it matches the 2. So this 8 would change to be 2 to the third power because 2 to the third power is 8. Keep the 2 to the y power. And then the whole point of changing the 8 to be a 2 was that now these cancel out. And so you get your final answer that y is equal to 3. So that's what we did before the break. Now that was really nice. That problem worked out to a nice whole number, and all the ones that I've given you come out to nice fractions. Only because I chose numbers specifically because they came out to be nice answers. So what Mr. Mostella showed you yesterday is what to do with numbers and problems where the numbers really don't go at all together, where they're just completely different. So that's where I use the change of base formula to evaluate them. So you can see the change of base formula here. So make sure that you wrote this down and know that one. So looking at this first example, example A, you have log 642. 6 and 42, even though 6 does divide 42 evenly, we can't change them using exponents to match. So then what we do instead is we do the change of base formula. So this is in the form log bx. And then, so really what we care about is the b and the x, the 6 and the 42. So using that change of base formula, you would set up the problem so that it looks like this. So I'd say log 42 divided by log 6. And then what I want to emphasize is whenever you're using this change of base formula, after you change it to look like this, in order to work this all the way out, you need to take the log of 42 on your calculator. Now some calculators you type the 42 and then press the log button. Other calculators you press log first, then type in 42. Regardless of which calculator you're using, the decimal you should get for log 42 is 1.623, blah, 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 some decimal that goes on forever. I just write like 2 or 3 numbers after the decimal, and I just use the number in the calculator. That way I don't have to round so much. So you do the same thing with the 6. So you take a log of 6 on the calculator, you get 0.778, something like that. Then your last step is to divide. So then you should get that your answer is something like 2.086. So then that's your final answer there. So basically what that says is, so that's how you work it out. An explanation of what that means is if I took this log 642, converted it to be exponential, it would say 42 equals 6 to the y. So what that means, that 2.068086 answer is 6 to that power is what equals 42. So that's how you do that. I noticed that a lot of people had issues with it yesterday. Another example, just in case you want to see another example worked out. So this one says log 45 of 12. So it goes log of 12. Because remember, 45 is your b, 12 is the x. So log of 12 over log 45. you work out each one of these individually. So log of 12 is 1.079. Log of 45 is 1.653. I've already done these on my calculator, by the way. And then when you divide, your final answer is going to be 0.652. So I just want to emphasize that this is how you work it out. Also, make sure that you realize that the number that goes on top versus the number that goes on bottom, doesn't matter which one's bigger or larger, it just depends on the position. So in this case, the 6 was the base, that's why the 6 was on the bottom. 42 was the x, that's why the 42 was up top. So that's just a recap of yesterday. Then for today, we're going to be doing the properties for logarithms. Now, just going back to the properties for exponents, because remember, exponents and logarithms, they're inverses of each other, they're opposites, so they're related, basically. So there's the log property, or you should know the product property. Basically, if you're multiplying two exponents, you add the powers. And then you have the quotient property, where if you are dividing two exponents, you minus the powers. And then so on and so forth for the other ones. These you should already know by now. So we're going to be using these two properties, actually, and kind of the power to a power property, but a little different in terms of what it looks like. So we're going to be using those two. So just know multiplication, you use addition, and division, you use subtraction. So that applies for exponential or exponents. Same thing applies for logarithms. So if you look at the product property here, you see you have log of b and then m times n. So because that's multiplication, you split it apart using addition. This logarithm, you have m divided by n, so you split it apart using subtraction. An easy way to remember is the fraction bar looks like a subtraction symbol. And then for the power property is kind of weird. Basically, the exponent, whenever you're taking the logarithm and it has an exponent, you take that and you move it up to the front. And you're going to do multiplication. So when you take the n, move it up front, it's going to be n multiplying the log. The inverse properties, we're not going to use these in this lesson, but we will later on. Basically, if the logarithm has a base and that base matches the number that you're taking the log of, they basically just cancel out. So these will cancel out and your answer is just whatever's left over. Same thing happens if it looks the other way. So if you have exponent with a base b and the logarithm has a base b, then they cancel each other out and you're just left with whatever else is left. So we're going to be using those, the product and quotient and power property for logarithms in order to expand these logarithms. So the first three, A, B, and C, are each unique types of problems. D, E, and F are just extra examples if you want to see more of each one. So looking at the first one, log b 4x. So 4x just implies 4 multiplying x. So keep in mind the product property. It says if you have multiplication, you split it using addition. So we're going to do that. So this would be log b of 4 plus log b of x. So notice that the order does matter. The 4 goes first, the x goes second, and also notice that the base stay the same. The next one, example B, is division. So I have 7 over x, which is 7 divided by x. Remember, you split division apart using subtraction. So this would look like log 4 of 7 minus log 4 of x. So that's what it looks like in expanded form. The last example, example C. So the 5 has an exponent there. Whenever you have an exponent, you can take that and move it up to the front. So then you're going to have 3 multiplying log B5. Now you don't really need that multiplication symbol there, so really what it should look like is 3 log 5 log b 5. I just realized that I wrote this wrong. So this was log b5. All right, so those three are unique. D, E, and F are just extra examples. So if you already understood those, you can skip ahead to the next slide. So example D has division. So 2 divided by 3 splits apart using subtraction. So log x2 minus log x3. Notice that the order, top number goes first, bottom number goes second, and division changes to subtraction. Example E is multiplication, x times y. So when you split it apart, it would be log 5x plus log 5y. And then the last one is the power property. So you have the 2 that's an exponent there, so it's going to move up to the front. So then your answer is going to be 2 log 3x. So that's what these look like in expanded form. Now these were the simpler types of problems where you only use one property. This next example is going to show you using multiple properties. So looking at this first example, expanding using multiple properties. So notice how I have x times y again, just like on the last slide, but then also the y has the exponent there. So the first thing you expand is going to be the multiplication. So this would split apart to be log 3x, and then multiplication splits using addition. So log 3x plus log 3y squared. And then to finish this one, you can't leave that exponent there. You got to use the power property, move it up to the front. Now you only move it up to that particular logarithm. You don't move the 2 up to the front of this. You would not do that. So then final answer, log 3x plus 2 log 3y. So this is what it looks like in expanded form. So that would be your final answer in terms of expanded form. The next example, looking at it, I see an exponent and I also see division. So two properties that we got to split up. So first split apart the division. So then it would look like log kx squared. Division splits the subtraction, log k3. And then can't leave the exponent there, use the power property to move it up to the front. So final answer is 2 log kx minus log k3. The 3 didn't have an exponent, so you can just leave that the way it is. So then another example, example C. Notice that this one's got even more going on. So you have the division and then also 2 exponents. So you're going to be moving 2 things. So first split apart the division. So log 7x squared minus log 7y cubed. And then final step is to take both of those exponents and move them onto the front. Now, obviously, once you get good at these, you can just do multiple properties at the same time. I just like to work these out step by step. So then the fully expanded form for this would be 2 log 7x minus 3 log 7y. So that's the answer for that. I'll skip the challenge problem. If you feel like doing it, you're welcome to, but that's just a leftover from my notes from last year. So here's your homework for tonight. So you have 2 of the using the change of base formula to solve, so using your calculator, just to make sure that everybody's got these down. And then for the expanding logarithm problems, you have 3 problems where it's just an easy type where you just have one property to split apart, and then 4, 5, and 6 are the ones like I just did where you have multiple properties and multiple steps when you expand the logarithms. Like always, if you have any questions, feel free to message me on SB.